I can talk. Yes.
Thank you. Sorry for the delay.
Yes. Dungeons and Dragons, Siege Warfare, and Fantasy, Defense in Depth. That's our talk. How do you manage?
Brought to you by.
Yeah, there's a little bit production through here. So, a little bit about us. So, I'm old and obsolete. Yeah, Amiga OS, D&D. That's my knowledge sort of stops there. Evan's the younger and smarter of the two of us, and he's not a people person, and I like to suck on guns. So that's yeah. Okay, continue. So here we go. This is a little bit about what we're going to be talking about. We're going to learn some lessons from the past. Networking, security. That's kind of what we're talking about. We're going to look at what we're doing now and try to forget about it because it's not working. Something about a bridge to the future. I forget that one. But we're going to predict the future, and we're not going to use a magic 8-ball. Call the psychic. We're actually going to tell you what. No, Evan's going to talk about the future because he knows. I have no idea. I'm stuck in the past, and we're going to talk about ways to try to secure the future, which Evan knows. Okay. All right. Let's talk about the past real quick because we're going to sort of talk about how we got to where we are now, and everything's a big full circle that repeats. And so, centralized computing. Any old mainframe users here? Yeah. Sweet. Okay, so some of you know. Okay, so there were these big, large shared resources. Yeah, huge. Yeah, information processing, number crunching. Yeah, blah, blah, blah. Okay, dumb terminals. Anyone still use them? They're awesome. Okay, so dumb terminals. They used them in the 60s, 70s. Big thing. Really cool. Then we had the smart terminals. Yeah, in the 80s, like the DEC BT series.
BT 100 for the win.
BT 52, 100, BT 200. Okay, and so these were all of a sudden dumb terminals that could do some local processing stuff. And that was kind of cool. That was fun. But then we sort of moved to decentralized computing, right? So now we have these personal computers. The computers they became personal, and so sort of forgetting about the economics involved. Let's just talking about the why they were developed. So they were kind of a reaction to mainframes. As my brothers once said, the individualized punk rock to their centralized disco, and they were symbols of power and individuality and freedom because all of a sudden you now had control of configuration and all the applications that ran. You could do it all locally. You had control, and that was really, really cool because you didn't have to rely on any kind of external system. Super fast computers. I mean, we had, and we're talking, kilobytes of RAM and endless megabytes of storage. What else? Would you need more? I don't think so. So that was a really cool sort of paradigm shift. I just like saying paradigm shift. Okay. So, and with decentralized computing, the files are inside of the computer. The computer. So now talk about where we are today, which is re-centralized computing, which is a term I made up. So we outgrew the traditional PC, writing things in BASIC and saving on a cassette tape drive. At least some people did, and I still do. But so you had the internet revolution. So that paved the way for all these incredible networking technologies, which increased networking speed. I mean, now remote remote files, remote resources, everything, it blurred the line between local. I mean, all of a sudden it was easier to find stuff on the internet, at least for me, than my local hard drive. And it's it's like, where did I store that porn? Or it's like I'll just boom, and I can find it faster. But that's because I'm kind of disorganized naming system. But so then you got cloud computing, and then that's all these as a fill in the blank as a service, and you had all these platforms that could do all kinds of cool stuff, and then you had, and I'm done. Okay.
We got it.
What does D&D or Siege Warfare have to do with it? I don't know, but I was so excited to talk about Dungeons and Dragons and it's not about that. So, all right, Evan's going to talk about some more interesting, relevant stuff. So, go for it.
So like,
Whoa.
Hello.
Hi.
Hi,
Evan.
So, a chronologically incorrect timeline of stuff, which is this process of warfare and what can we learn from the past to the future and all that good stuff. And, you know, the big deal is that, you know, sword beats clubs and, you know, walls beat whatever. And, you know, by the time you get around, you've got this, you know, holy hand grenade and random ninja dude with a computer. But the whole purpose of this and kind of the goal in the talk is to kind of look at this aspect of the escalation of warfare and the advances in armaments and how we can kind of do a little fantasy prediction into the future based off of all the stuff we learned from the past. So if we take warfare, we hear that word warfare get thrown out all the time. You know, if this is war, then why or where's our strategy? What have we learned? So you know, it's kind of funny because what changed in this process at some point, we learned things that became more important to us, like, you know, the other guy has a bigger gun or something like that. And so this shift happened into how do we, you know, how do we predict the next piece? Like, what's the next assault going to happen? So if I can predict it, I can get ahead of it, things like that. So intelligence, there was this shift into intelligence that became very key. And how do we do the operational, strategic, the tactical advantages and things like that. And then we saw things like the Enigma, you know, breaking the Enigma code and things like that just drastically changed how this, you know, the process of World War II happened and ultimately impacted, you know, the outcome of the war. And so we see this importance now. So we say we're in cyber war, like what's an example of you know, what's really happening? This is the perfect example. I mean, the F-22 fighter, anybody know what that thing is? I know it's a plane, I have no idea what it does. But yeah, it blows stuff up, which is cool, I guess. But this perfect example of intelligence being paramount to mitigating threats and the power that it has to, you know, help you defeat your enemies and that type of stuff. But, you know, where were the techniques to root out the spies that, you know, that we saw in this? Where was, we've got all these perfect examples of Flame and Red October and this shift in importance of intelligence and learning ahead of things. And so, you know, then everybody's still on the same page, we're still tracking, all right, cool. Because we're in the danger zone. Archer fans here? No?
Oh, yeah.
Yeah. So let's forget the present, I guess. That was, try to forget it anyways, like what we're doing now, because arguably some of it works, some of it doesn't. But would you agree, like we have no security problems right now at all? That's why we're here right now.
Simpleton, fool.
You know, so kind of setting the stage for this next little piece, because we're going to play a little game called Fantasy Defense in Depth, and it sucks, but it's funny anyways. And you know, but if you ask your CFO, they can tell you, right? Like as time goes on, security is going to get better or stay the same, and that as we increase and automate and buy more products and stuff, we just need to either throw money or time or whatever, and that cost will go down and all that argument of crap. So admin dude, we're going to play this game and we're going to set some context here and do a little role playing. Who likes to role play? And yeah, all right. So we're moving this along. We're going to look at a completely exaggerated and fictional example that has never happened before. And yeah. So admin guys, we got admin guys in the room? No. Okay. Security guys. Audience participation. Who's totally ignoring me right now? All right, cool.
I forgot to mention one thing. So while Evan was kind of maybe drinking last night, I was the last one with the slide deck, and I put in a couple of new slides that he hasn't seen yet. Okay. Enjoy.
As long as you didn't mess up.
No, I didn't mess up the one. No,
Okay.
just one.
Okay. If my notes don't come up on the screen, it's going to get really ugly. So, you know, we've got this defense in depth, you know, admin guy comes in, or admin guy's protecting the network or whatever, security dude comes in, he's doing an audit or something like that, and this never happens, right? You've never had that, as a security professional, never had that admin guy be like, I have a kick-ass network and you're never going to get in. right? We never get in, like bad guys never, anyway, sorry. He took off, I also noticed he took off like the next slide view, so I don't, it's kind of like a little fun with that. So, there we go, all right, so down the rabbit hole we go. This is where the D&D comes in, right? I've got my +8 firewall. He's defending my network, and I have my arsenal of stuff, and I've got my wizard sim appliance, and he gives me +5 powers of divination or something like that. And, you know, and even if security dude does get past all of this stuff, you know, I'm gonna be there. None shall pass. Then I've got my evil bunny, and he's going to gnaw your face off, and it's going to be unicorns and rainbows, and so let's we ready to play a game because I started talking, right? So let's see, admin dude's ready. Let's go. How do we play? Tower defense. Anybody love tower defense games? Know how to play them? Yep, cool. So I'm not even going to talk about the end of it. What happens in tower defense games? Like, we build our castle, and anyways, do you ever win? I don't know. Okay, maybe you do. Yeah, so let's gather our resources here. We've got all of our stuff in the arsenal that we could choose from, but the key point in this is we got to choose our weapons carefully, right? We've got a lot of fun stuff, and some of it's really expensive, but we have unlimited resources, and we never run out of, there is no thing as money, and, you know, yeah, I use buzzwords all the time to defend my network, and it keeps people out. I promise you that. It works. So we got our resources, right? We're ready to go. How do we now we prepare for the siege? And okay, good, you didn't mess with that. So we're still playing the defense in depth game. And but now you've got all that stuff, and you've never like tied your arm behind your back trying to manage all that, have you? You know. Yeah, so I'm so busy configuring and monitoring all my stuff, my arm just fell off spontaneously. So, ready? Let's play. So we've got our stuff. We're preparing for the siege. So, example number 1. All right, this is round number 1. Anybody heard of phishing? I heard. I just became aware of this marvelous new attack methodology. Because we've learned here that this works, right? It's they're never going to get through all of that stuff with an email. Like, that's just so inconceivable. But that's a bad example, and so we're going to like go on to the next one, which is not that. But so the next iteration of the phishing example, right? You know, the next iteration of the phishing example is like the thirsty developer and the watering hole attack, right? So. So now we have the guy going through, and you go download a tool, and because that tool is completely safe and trusted, these guys in these Chinese forums, they are so helpful, and the India guys, they love to give me code for free, because anyways, all right, yeah. So Evan, not the old example, but it still works, right? I mean, any testers in here, pen testers, does this still work for you guys in the organization? So fail. We lose round 1. Yay, this one did make it in there. This is my favorite picture. Yes. So we're not losing any arms here, I'm sorry. No, you want to do an example here, Chief? No. Sorry.
Did you put the dice in your mouth?
No, go. No, go ahead.
Okay, I'm hogging the podium here, and he likes it. All right. So slide number, the next example is, admin and security dude, OSINT. Do we have any OSINT people in the room? Does anybody even know what the heck that means?
Yes.
Yeah, they've got an awesome presentation on Noah and Sky on Sunday. The DEFCON? Yeah. So we're so thankful that users put all this information for us to break in, but we do not use the cloud organization. We have policy. We have taught our users not to click on stuff. Like, they know, right? And there comes this realization that, oh crap, our stuff is starting to leave the cloud, or going to the cloud, even though we don't use it as an organization. And anybody who's seen a customer like finally make this realization in their head?
Oh yeah.
here I was thinking this stuff was going to kill.
But Dropbox is so convenient.
I'm still waiting on that mass suicide now. I can tell. It's just you guys are like losing me. And wait. There's porn on the internet.
What's that?
He's left-handed.
He is left-handed, yes, he's left-handed.
All right, moving on. So does anybody? I mean, let's just come to the agreement. Like, we've lost control of this stuff. It's there. It's being used. Like I said, we've got this policy that nobody's going to use cloud. Nobody's going to use their personal device to check corporate email, and that we can stop them even if we had to. Right? There's no way they can use their iPhone or web browser to access OWA because that's we give them all Blackberries. So it's fair. So game over. Is the game over? It's this. All the stuff that we've done, it's like reactionary, right? We've put devices in place that try to protect against known attacks and things that we think might happen and all that good stuff. But where do we change our focus to get off? All right, moving on. Protecting devices, keeping people out, that good stuff. Like, we have to learn to anticipate and expect breaches and control them. You put those dirty dice up on me. So I keep having to check, like, is what's here really up there, because I don't know what it is. This prevention is fuel. There's a little organization called Gartner, and even the troglodytes of Gartner understand that prevention is fuel, and they're this concept of continuous compromise and financially motivated attacks. Sorry, I'm trying to get this off here. So if we listen to vendors, that's not going to happen. Right? We are in control because we bought their product, and we didn't just DOS ourselves by buying a bunch of stuff and now we're trying to configure it. So if you're here, anybody planning on going and seeing a talk on any of these things up here right now, like active defense, collaborative defenses, those types of things. This is not a talk about that, so don't worry, I'm not going to bore the life out of you. Sun Tzu says no, you're enemy, blah, blah, blah. So all of that stuff is really about like returning fire, right? We want to attack them back, and sweet, it worked. So, philosophically though, what we've just been talking about is, so we're following this progression of loosely strung together insanity and stupidity on our part. That philosophically we're fighting a battle that it's not going to end, and there's not really a way to win it. It's just about continuing on, right? So now we're ready to pull out the magic 8-ball and predict the future, maybe. So you were gonna.
Oh, sorry.
Yeah.
I forgot I'm part of this talk too. Okay, I do that. Hold on. I'm turning my phone on. Sorry. Yeah. This one. So, pervasive computing, ubiquitous computing. Who's heard of that? Like 2 people, 3 people?
Nobody.
Okay. Oh, okay. Anyone using it? No, it's not out yet. No, I will. So, pervasive ubiquitous computing. So that's like humans and computers they're the same ecosystem. They're directly interacting and affecting each other on this continuous basis, and we're surrounded by all this telecommunication technology, and there's a seamless integration of everything, data, services, and it's going to be awesome. Or not there yet, but 2 kind of principles. There's context awareness, where the computers will actually understand sort of the situation in which the user is requesting information or services for. It's the content, and will provide it accordingly, just magically. Natural interaction, so supplying services. What did I just do? I messed up. Sorry. So concept of natural interaction, supplying services or resources of information without the user having to worry about how the computer's doing it. So it's not like, okay, I'm going to open up a Google image search and to search for Jana Jameson. No, you just say, I want porn, and it comes. So it's just like that seamless interaction with what, yes,
It's
question.
learn about your preferences though, isn't it? Over time, I mean,
Yes.
great system.
Yes. No, Iron Geek for you would be, I want amputee porn. Yes, and so it sort of depends on.
But I know Nazi midget Eskimos.
Yes, that's.
We call Little Sports Star.
That's in the next patch.
No.
Release 2.0.
So that's the idea behind sort of this pervasive, ubiquitous computing, which is coming to a store soon. Well, now developing security for it. So we have this inevitable pervasive computing platform, and it's going to happen. It's because we no longer sort of think of going to, it's a place, a work is not a place you go to. It's a thing you do. Yes, I didn't know that. But no, really think about it. It's not, so this whole sort of idea of, sort of boundaries of, it's the network perimeter, it's now dynamically going to be changing, it's going to be eroding, it's undefined. So trying to come up with a security architecture for a system like that that's a very difficult task to actually design and implement effectively. And of course, as all products, we build security in from the beginning. It's not like an extra layer that we put on top, right? Right. Yeah. It's always never an afterthought. It's always integrated. So we need to sort of think about how to do this now before it's actually released to the public. I think you can bid for ubiquitous computing platforms, but I wouldn't recommend it. Think about actually sort of in terms of PC to user ratios. Like, okay, old school would be like one PC, one person, right? Maybe better. Now, what is it? Everyone has how many computers, or connected devices, like what, cell phone,
9,
computer,
10.
laptop, iPad, right? Apple Newton. I mean, you have many, so it's like 1 to n, where n is like a single digit. Then, with ubiquitous computing, you're going to have like 1 to n, where n is in the double digits. So with this kind of this scaling now, it's exponential growth or really steep linear growth. Trying to scale the security architecture to fit that, traditional security methods aren't going to work. We have to find a way to build it in at a core fundamental layer, which is something that Evan has done or figured out and is going to talk about right now. Go.
Jump in. Tag. All right. Check my slide. I'm sorry. All right. Principle of that. So I guess here's the thing that kind of irks me a little bit as a security professional is this whole concept of that we can.
Nice. Make it sexy time. So,
all right. Let's do that. Let's see. This idea that like right now it's all about data loss prevention. How many organizations do you have that actually use this? I've seen a couple, and it sucks. It's all about keeping people from burning the CDs and things like that. So pretty dumb in my opinion, but we're losing this battle, so why aren't we focusing on data protection? And the concept of ubiquitous computing and your data being everywhere and available all the time from whatever you're on and all that good stuff, you can't always enforce protection of the device or protection of the network or whatever it is. And so as Noah said, we start to lose control of this aspect of where data is and how we protect it, and do we even care about devices anymore? Is the information more important, like in the shift of information warfare from traditional defenses into information-based warfare and all this type of stuff? Is that progression, are we trying to scale in that mindset? So we take this concept of the information security is a three-dimensional thing, that it's based on multiple facets. And so if as the lines get blurred between devices and services and all that good stuff, anybody's mind getting just completely warped trying to figure that thing out, because it's very confusing. Thank a guy named Macumber for that one. The Macumber cube, and so we just. But anyways, if we stop thinking about it in the context of where our information is and that type of stuff. So like a lot of cloud storage, a lot of ubiquitous computing principles and things like that that we're using now, they kind of look like this. Like we have protection in transmission, and maybe it's confidential in the transmission of it. We can keep integrity kind of around this aspect of, but integrity is more important in a lot of services now than security of transmission or processing, and then availability starts to be limited because if we implement encryption on everything, then we lose functionality for search or something like that. So how do we it's this battle for resources, not just in an aspect of the computing piece of it, but from an information security aspect of how do we wrap our heads as security professionals around a three-dimensional issue, which, humans and technology, maybe the technology can completely protect us, but then that takes away or limits us in what we can do as far as availability or something like that. So honestly, I think this is the best we could ever probably hope to get to, would be something like this, because people are stupid. And if you didn't figure that out yet, okay. So how can we get as close to this as possible is kind of the goal. So we're going to talk about an idea that I had and went all beautiful mind all over a mirror in a hotel room a few weeks ago. Surprise!
One, cut a hole in the box.
So this is probably going to get cut off, but here's a concept. So the idea in ubiquitous computing and stuff like that is that we have this store anywhere, we mentioned earlier, this store anywhere, available everywhere, regardless of what OS or what device you're on, and that's not advancing. That we want to use any algorithm that we can use. We don't want to lock ourselves into a particular encryption framework or algorithm, and that we shouldn't have to build entirely new methods of communications, and we shouldn't have to wait for IPv10 to make this work or something. And that what that says is support for multiple access control methodologies, because the framework can be shifting, especially as we talk about you've got ABAC, attribute-based control, and all these different things that are coming out all the time, that NIST and all those wonderful people come up with these great ways for us to wreck our networks. And can we incorporate something that's really big right now is incorporating trust into that context of how we interact with data and devices. Do I have you see the CVSS scores and all that kind of stuff, that's about trust, right? How much security, how can I trust that device isn't going to get compromised? And some of the other things that come into this are, how do we protect the data and put it in the cloud without disclosing what's inside of it? So we don't want to give our data to Google because they might do something with it, like sell it to everybody else, or
No.
Really?
I'm predicting the future here, guys. All right, they may want to do that one
They'll
day.
actually be data
Oh, that's it. Yeah, Prism. Prism. So and then the next version of OS X Mavericks is going to have data tagging and all that good stuff, so that you have these new contexts that you can group files in, regardless of where they are in your operating system and things like that. So obviously we're going to drink this magic potion, and we're going to have plus 10,000 to the power of my D&D security app.
Is it like a hit points, let experience points? Because you never played.
AI. So we're searching for the Holy Grail, right? So we're going to keep going. So here's my idea, and this is probably going to take up as much time until they hook me off the stage, because it's a very complicated topic. And what if we had scalable profile PKI encryption designed for ubiquitous computing? So we're talking about the cloud here. The cloud, it's in the computer. Active access control, so the methodology for how access control of devices and services and things can change over time, or can change in context to policy or whatever it may be, because we recognize that we're not hacked now, but we might be hacked in 5 minutes, and how do we anticipate a breach, so how can we respond accordingly? And then what if we had these aspects of file management, because file management systems work so well now, and possibly allow us to do data destruction with PKI. If we're doing this, all we gotta do is destroy the private key, right? And then it's useless, the data is gone. And you do this through certificate archiving and revocation. Maybe we give data like an automatic kill switch, which is that if you're not active, it's only got 6 weeks or whatever to be used, and then it dies or something like that. This concept. Any takers here who's smoking weed at this point. I got some Kool-Aid right here. So I have no idea. So this is where the complexity kind of comes into this. All right. So we take it in context. We have an app, and so we're going to go around this little slide here, and this is going to take me a minute to get through. So hopefully there will be no mass suicide. It's very boring.
What not boring?
Okay.
Can I get over here?
Yeah, Uno Mas Cerveza. So we have some of the protection mechanisms that we have for apps and devices currently involve certificate pinning, ASLR, SE-HOP, all these great things. So we're relying on those things to help us protect our applications. We have all these other aspects of devices and things like that that are being protected at different layers. So if we think about it from an OSI model, encryption is supposed to happen in the presentation layer, but the reality is that it's all over the place. It just depends on how the application developer decided to implement it and all that good stuff. So, but we sign our app with some type of a private key that identifies the individual that's running it. And if we create a security context for users accessing the application, have some type of identity that they're logging in with, and right now we have the capability to give them public and private keys and all that good stuff. So that's not, we're there at that point. And so if we move forward, like the user interacts with the app in context to some identity that they've received either from Google or the cloud provider, or maybe it's from their domain or whatever it is, and they create a file. Everybody with me this morning?
Yep.
All right, you suck, Evan. So what if so we take this, we've got right now we've pretty much just described like PGP, right? We interact with it, we encrypt this app, or encrypt this file with our with our keys and stuff. But what if instead of just encrypting the file, if we want security in transmission, we want that magic holy grail stuff, how do we send data across networks without disclosing content? How do we protect our data so that I can be sure that the people that the person on the other end is the only one that can receive it? Because SSL and all those other ones, they have never been attacked. They are perfect. I hate you. So what if we stop thinking about public-private keys just for in the context of users and extended that out to, like we talked about applications, what if we extended out to servers or services, and servers and services and all these types of things, they all get their own public-private keys as well. Now, we're not going to get into how I do key management and all that good stuff. Yes, drink that as fast as you can. Or actually drink it very slowly so that I can't bother anymore. So this concept of when we get into these more advanced active control, active access control mechanisms, they introduce this concept of a policy decision point server, which is what's making the decision on how your context or your interaction with files or OSs or
No, don't leave.
yeah, we suck. All right. So then we send our file through. What if we encrypt the file with the public key of our domain, and the only person that can open that file is the domain? So maybe it's Google or whatever. Maybe we've encrypted parts of the content of that file, etc. But we send it down to a server, and our policy decision point interacts with the data, identifies content, and maybe it's social security numbers. Maybe it's something that we want to protect. And the decision point server can interact with it and create contexts for how that data gets protected. Maybe it's only allowing certain users to interact with social security numbers, and so they have a role-based access control metric or role-based access piece that does that. So your identity server then has attributes. Use role-based access control mechanisms. You have attributes that you're monitoring or preventing access to, things like that, and just different policy settings is what that little cog for. What if we give each of those their own set of public-private keys, and then they take that and they add to the file. So now we have journaling, we have the context that we can, that data can be segmented and partitioned away from others, and that if you do not resolve those keys, if you're not a part of those groups and everything else, perhaps that journal file, and you can do mandatory access control and all that good stuff. I'm probably telling how did you get to this from the stuff we were doing earlier? I honestly don't know. So we create this file in context, and then we want to make sure that it's secure and encrypted all the way up to and that the only other person that can open it is maybe our cloud provider. So then we, again, take that file, and the policy decision point can forward it out to Dropbox or whoever else, and they're the only one that can open it because we've signed it with a public key infrastructure. So now it's in Dropbox's hands. And so now I can turn around and the cycle can continue, that a user can interact with their data through the app again and all that good stuff. So how does this scale? All those good things. And I'm just glad that I got through that, and most of you look like you're still alive. So I was worried for a bit. So what does the content of this file look like exactly? Honestly, I have no idea because our testing it's been interesting. So if I can still have, because this is a journal file, I can still have portions of the document that are encrypted only for me under my identity, and I'm the only one that can open. So I've now got an aspect of, here that I can send that through to all these other servers and services, but the data that's important to me, I can keep private from them. So it's not limiting your availability of that file, it just restricts access to you. And then we journal other pieces of it. Maybe I have data that I want to share with another member of the organization so they can collaborate with me on the document. Again, those get signed and encrypted by, maybe it's the attribute public-private key set that encrypts that. So then as I reverse resolve that key cipher, if I'm part of the organization, I have an identity that resolves that, then I can then open the file. So, and it allows us through journaling to add and add and add and add and all that good stuff. And so the integrity of the file can be maintained regardless of who touches it. I can build trust based off of who's touched the file, what they've added, and what they may or may not have been able to see based on time and context. And anyways, this gets kind of big after that. And
Oh man.
I don't know. I don't know. It just
can't see that. All right, I'm gonna move on. Sir Grumpy Cat, he hates encryption, by the way. I think we're doing okay on time here, but it's a much bigger, the concept of this is much bigger, and we've actually outlined and diagrammed and started doing some proof of concept of this, and the reason that we're coming and presenting something like this here is the aspect of that it's not going to work unless we create something standard that everybody would use. It's a framework. It's not meant to be it's not meant to be like in the next release of Microsoft OS, whatever. Everybody has to use it. So our focus is focusing on data protection, not loss prevention, which is like the next cycle of products that you're going to have to buy because somebody told you that you had to. So we're working on this. We're calling it Presentation 6.5, Presentation Layer 6.5, for encrypting all the things. You won't hear that again for the rest of the week at all. All the things. So, pentestfail.com. We break stuff and do stupid things, and Noah sexually harasses me.
happened like twice.
So, are we good? Yeah. All right.
Questions?
Questions?
Lady over there.
Insults.
One. Yes, ma'am.
Yeah.
Yeah.
So two-part questions. How are you planning to monetize this, and how are you planning to merchandise this?
Does the box have lights on it?
No, I mean, that's the whole point, right? It kind of goes back to what I said.
You're talking to this thing.
Get off, I'm sorry. Yeah, no, the aspect is exactly that. If we monetize this, if we do something, then nobody else is going to get to take advantage of it. So it's all about it being available to everybody, it plugging in, having this presentation 6.5 type of thing, plugging into, because it has to be pervasive, right? How do we make it pervasive? How do we, that's the challenge that we're facing right now. So there is no money involved in the development of this. This is all just me and a few buddies that, I'll back up real quick. A special shout out to John Collins, who's coding a lot of this stuff. I had some slides in here on what we were doing, but we knew we weren't going to have time to talk about every little bit of, like the web ontology frameworks and things like that we've actually used to build this stuff, or stuff we stole from IEEE that sucked, but we're going to use it anyways. We don't want to write something new. We want to use existing stuff and stuff that's out there already, because that's how we get mass adoption. That's how we get critical mass. And so we don't have the code published up, but right now it's written in Java, Boo, Java, or Unicorn Boo, as I like to call it. But that's just what we know, and we're hoping to open up the audience and open up the developer contributions. So if you've got skill set encryption and developing framework technologies that can be written in whatever language your iPhone wants to use next type of stuff, then please hit us up and join in.
In terms of monetization, if you notice, We both, yeah.
We work with Microsoft.
Microsoft, yeah. No, we don't work with, yeah, we have these things that say Microsoft on it, but yeah, I don't know where we got this from, but.
I can make you one if you want.
They have a great business model, and we're hoping to follow what they've done in the past. So, secure software at a reasonable price. Other question? Yes.
I lost track of the self-destruction.
Yeah.
Was there a thread pulled there that carries that through?
Well, the idea is that if we talk about trust and that kind of stuff, so all I have to do is revoke the certificate of that file so it won't resolve anymore. So when it comes back, like I said, I know it's a really complex thing, but the idea is that the data that's encrypted with that key can no longer be unrendered theoretically, right? Because the certificate is no longer valid. So it's just like certificate revocation OCSP that you have now. You go to a site and it says this is no good, but those private keys for context or users belong to them, so they're withheld. It's not like you can say, well, I will choose to resolve it anyways. It's to unencrypt it, you have to have the private key, and your policy decision point server holds it, and they can say, I'm not going to allow you to use it anymore. So that data effectively becomes unusable. Does that make sense?
Question.
So you guys red modeled in any way that really complex piece that you kind of showed? I mean, you're bringing policy machines and stuff, you just give them more of an attack surface to play with.
The only thing yes, you have more of an attack surface, but the only thing that it would do for you, I mean, you'd have to if you got all the private keys to everything, that would be what you'd attack, but it's no less complex than what we have now. I mean, we're talking about, it's just like Active Directory. Think about PGP plus Active Directory plus PGP in the most simplistic of terms. There are devices and beasts that you have to have out there already anyways.
But neither of those are really that secure, so you're building a new interesting amount, something interesting, but you're doing it on a very weak foundation.
It doesn't have to be. I mean, the idea too is that the only thing that I care about trusting anymore, I don't care about devices at this point, because I can build context based on devices based on attributes, and I can say I don't trust that device, therefore the data I won't even allow that file to be released. So I don't care. I'm going to have to rely at some point on. That's why we call it 6.5, because it has to sit at layer 6.5 or layer 6 for presentation layer security. So I'm going to rely on application level protections like SE hop and memory allocation, stuff and all that good stuff. I'm going to rely on sandboxing and all that stuff because I can't fix that stuff and I can't keep developers from using it. And I've got to rely on lower level stuff like at layer 5 for session control and the security mechanisms that get applied there. The reality is that there's this misconception, I think, by a lot of developers that layer 6 has to be, getting the hook. So we can talk about this offline. But thank you very much.
They'll be releasing with the Prism API, so that'll be helpful as well. And the other thing is, this is no substitute for homomorphic encryption, which, anyone have any solutions for that? No?
You said
homomorphic encryption.
homomorphic?
That's not gay encryption. No, it's homomorphic. No, you encrypt stuff and it stays encrypted and you perform function. It never gets decrypted. So which is sort of the holy grail of crypto, but that's, anyway. Okay, sorry.
Someone buy you a beer and ask you that question.
Thank you for listening to the rambling, and if you are interested, stick around.